Welcome to Sleeping with Science. It's so good to have you here tonight. Before we begin, give yourself permission to slow down. Perhaps you're already lying in bed, wrapped in the quiet comfort of a blanket. Maybe you're on the couch, lights turned low, a cup of tea cooling within reach. Or maybe you're listening while the world outside still hums with activity. Wherever you are, this moment is yours. Nothing is required of you. All you need to do is listen, breathe, and let yourself drift. Sometimes sleep comes quickly, other times it takes a little longer, and that's perfectly fine. Because even if your eyes stay open a while longer, you'll still leave with something gentle and valuable, a small piece of wonder about the world around you, and the science that makes it so extraordinary. Tonight, we'll explore something so familiar that you probably don't give it a second thought. Water. It's beside your bed in a glass. It taps softly against your window as rain. It stretches endlessly as oceans that paint the earth blue. But here's the remarkable truth. The water around you, the water inside you, is older than the earth itself. Every drop, every molecule that touches your lips or moves through your veins carries a story billions of years old, a story that began before our planet even existed. Picture yourself lifting a glass. The surface trembles slightly in the light, so ordinary, so simple. Yet in that glass is hydrogen, born in the very first seconds after the Big Bang. In that glass is oxygen, created inside colossal stars that burned brightly and then collapsed long before Earth was born. And when those atoms met, in the quiet depths of interstellar space, they joined together to become water. The very same water that quenches your thirst tonight. The very same water that flows through every living thing you know. It's humbling to realize how ancient it is. You use it to wash, to cook, to cry. It is woven into your cells and tissues. Yet it is also a message from the universe, a memory carried from the fires of creation. What seems so ordinary is, in truth, extraordinary. As you listen, allow yourself to rest with this thought. The water that nourishes you tonight was already traveling through the cosmos when the earth was still molten stone. It drifted quietly in clouds of dust and gas before finding its way to our young world. It is older than the tallest mountains, older than the oceans themselves, older even than the ground beneath your feet. Imagine one drop, just one, making its patient way across billions of years, only to arrive here with you now. This is just the beginning of our journey together. In the chapters ahead, we'll follow water further, from its cosmic birth to its arrival on Earth, to its endless cycle through time and life. But for now, let the thought of water as a whisper older than the Earth accompany you. You are part of this story too, carried gently by the same molecules that once shimmered between the stars. As you settle in, let your breathing soften. Let your thoughts drift like clouds across a wide sky. There is nothing to solve, nothing to chase. You are here simply to listen, and whether you close your eyes and drift quickly into sleep or stay awake a little longer, you will leave with something gentle, something to wonder about. Tonight, we begin with the simplest element of all, the quiet foundation on which so much of the universe rests: hydrogen. Picture for a moment the universe at its very beginning. Not the stars and galaxies you know, not even the space between them, but a moment before anything recognizable existed. The Big Bang had just unfolded, not a bang in the way you might imagine, but a sudden expansion, space itself stretching outward at unimaginable speed. In those first fractions of a second, the universe was impossibly hot and impossibly dense. Particles blinked into existence, collided, vanished, and appeared again. A storm of creation where nothing held its shape for long. As the universe cooled, that chaos began to settle. Protons, the positively charged cores of atoms, found a kind of stability. Neutrons, carrying no charge, clung close to them. For a brief time, light itself could not travel freely, trapped by the dense fog of particles. But gradually, as temperatures dropped, something lasting began to form. Those protons, simple and steady, would become the seeds of hydrogen, the first element. Hydrogen is astonishing in its simplicity. At its heart, it is just a single proton, sometimes with a neutron beside it, orbited by a single electron. One proton, one electron, the simplest atom nature can build. And yet, from that simplicity, everything else arises. When you think of stars shining in the night sky, burning with unimaginable brilliance, you are looking at spheres of mostly hydrogen, their light powered by the fusion of those simple atoms. Imagine this. In the early universe, about 3 minutes after the Big Bang, hydrogen was already abundant, making up the vast majority of matter. Nearly 3/4 of everything around you now is still hydrogen. It is the quiet majority, hidden in the fabric of the cosmos, flowing through stars, drifting in interstellar clouds, and waiting patiently for the right conditions to create something more. Without it, there would be no stars, no oxygen, no water, no you. Let yourself picture hydrogen not as a scientific abstraction, but as a kind of ancient breath. It has no color, no taste, no scent. You cannot hold it in your hand. And yet it is everywhere, the most common substance in the universe. In the water you drink, 2 parts of every molecule are hydrogen. In the energy of the sun warming your skin, hydrogen atoms are fusing, releasing light that crosses millions of kilometers to reach you. When you breathe, when you move, when you dream, hydrogen is always part of the story. The beauty of hydrogen lies not only in what it is, but in what it allows. Alone it is simple, a proton with an electron circling like a faint echo. But given time, given gravity, given the quiet patience of the universe, hydrogen gathers. It drifts in great clouds that stretch across galaxies, and when enough of it collects, gravity squeezes it until the atoms collide, and a star is born. That fusion lights the cosmos, creating the heavier elements, including oxygen, which will one day meet hydrogen again to form water. So while you drift towards sleep tonight, remember that the universe's oldest building block is still with you. The hydrogen in your body, in the water you drink, in the breath you just took, is as old as time itself, created in those first minutes when the cosmos was brand new. It has traveled for billions of years, unchanged at its core, patient and enduring. The simplest atom, the first element, quietly holding the story of the universe in its single, steady proton. And if sleep begins to fold around you now, let that thought drift with you. You are cradled by hydrogen, the universe's first gift, a soft reminder that even the most ordinary things are born of something eternal. Let the sound of these words arrive gently, like waves that reach the shore and then slip quietly back into the sea. You do not need to hold on to every word. You do not need to stay awake if your body asks for sleep. If slumber comes, let it take you. And if it lingers, then you will simply spend a little time wandering together through the story of the universe. In our last chapter, we met hydrogen, the simplest element, born in the first breath of the cosmos. But hydrogen alone is not enough to make the world as we know it. To form the water that fills your glass and flows through your veins, another partner is required, one that is heavier, rarer, and more complex. Tonight we turn to oxygen, a gift created not in the first seconds of the universe, but in the fiery hearts of stars. Let your thoughts drift to the life of a star. It begins quietly, as a vast cloud of hydrogen and helium drifting through space. Slowly, gravity gathers this gas, pulling it tighter and tighter until the pressure and heat at its core ignite nuclear fusion. For millions or even billions of years, a star will live by fusing hydrogen into helium, shining with a steady light that warms surrounding planets and fills nearby skies. But eventually, hydrogen in the core begins to run low, and when it does, the star must find another way to survive. It is in this struggle that oxygen is born. As the star grows hotter, new reactions begin. Helium nuclei fuse together, creating carbon. Carbon collides with helium again, and oxygen emerges. These processes take place at temperatures and pressures beyond anything we can imagine, trillions of times greater than what we feel on Earth. Deep inside the star, atoms smash together, binding in ways that release immense energy. Every breath of oxygen you take tonight was once forged in such a furnace, at the core of a star that lived and died long before the Earth came to be. But the story does not end with creation. Oxygen would remain trapped inside stars if not for their endings. Small stars, like our sun, will eventually shed their outer layers gently, spreading gas and dust into space. Larger stars live faster, burn hotter, and die dramatically. When they collapse, their deaths explode outward as supernovae, scattering the elements they have made across the galaxy. Oxygen, along with carbon, nitrogen, iron, and countless others, is flung into the dark, mixing with hydrogen in vast clouds, waiting to become part of new stars, new planets, and eventually, new forms of life. Think about that for a moment. The oxygen flowing through your blood tonight, the oxygen in every breath you take, was once at the core of a star. It burned in a furnace beyond comprehension. It endured the violence of a stellar death. It drifted across space, perhaps for millions of years, before finding its way into the cloud of dust and gas that formed our solar system. From there, it became part of rocks, oceans, and air. And now, in this quiet moment, it is inside you. It is easy to think of oxygen as ordinary. We notice it only when it is missing, when the air feels thin or our breath short. Yet it is the element that allows fire to burn, plants to grow, and animals to live. It is the partner of hydrogen, together forming water, the substance that makes our planet unique. Without it, Earth would be barren and lifeless. With it, Earth is blue and green, alive with rivers, forests, and people who pause at night to wonder about their place in the cosmos. So as you close your eyes, let the thought of oxygen bring you a sense of connection. You are breathing starlight, carrying inside you the legacy of suns that lived and died billions of years ago. Every inhale is a reminder that you are part of a story that began in the hearts of stars. The universe did not simply build you from dust. It built you from fire, from light, from the quiet generosity of stars scattering their elements into the dark. And tonight, as you rest, you carry that gift with you, a soft reminder that you are made of the cosmos itself. Tonight we drift deeper into the quiet reaches of the universe, into places where light itself struggles to travel, into clouds so cold and dense that they almost seem like shadows stretched across the sky. These are the molecular clouds, the dark nurseries of stars and planets, and it is here that two ancient elements first begin to find one another. As you listen, let your body grow heavy against the bed or chair where you rest. Let your mind loosen, wandering gently like mist, and if sleep takes you before the story ends, that is perfectly fine. And if you stay awake a while longer, you will carry with you the image of a universe weaving water long before Earth was born. Hydrogen was waiting, abundant and simple, spread throughout the cosmos since the very beginning. Oxygen, heavier and rarer, had been forged later in the hearts of massive stars and then scattered across the galaxy in their final bursts of brilliance. For ages they drifted apart, like dancers who had not yet met. But in certain places, where gravity gathered clouds of gas and dust, conditions grew right for a union. These regions were so cold that atoms slowed down, so dark that starlight could not pierce the shroud. Within this stillness, chemistry began to unfold. Picture a vast cloud of hydrogen, stretching across light years, silent and invisible to human eyes. Tiny specks of dust float within it, grains made of carbon and silicates, fragments from ancient stars. These grains act like little stages where atoms can meet. An oxygen atom, alone and restless, attaches itself to the surface of a dust particle. A hydrogen atom drifts close and binds to it. Another hydrogen follows, and suddenly there is something new, H2O, a molecule of water. The process is slow, almost unimaginably so. Collisions are rare in the thinness of interstellar space, and yet given time, patience, and countless opportunities, bonds form. What is astonishing is that most of the water in the universe is created in these quiet conditions, not in roaring explosions or blazing fires, but in the hushed darkness of cosmic clouds. The water made here coats the dust grains in thin icy layers, turning each speck into a tiny frozen treasure. Over millions of years, entire clouds can become laced with this invisible frost, hidden from view but present in staggering amounts. Astronomers have peered into these regions with radio telescopes, instruments that can detect the faint signals emitted by molecules. And what they have found is that molecular clouds are rich with water, so rich that some contain enough to fill oceans 1,000 times larger than all the seas of Earth combined. These clouds cradle not only water, but the ingredients for life itself, complex molecules waiting quietly for the day when they will be part of planets and living beings. There is something deeply soothing about imagining this chemistry unfolding in darkness. No rush, no noise, no fire. Just atoms meeting gently on the surfaces of dust, joining together into something greater than themselves. Out of this patient process, the universe creates one of its most essential gifts. The water in your body, in your cup, in the oceans of Earth, began its story here, in places so quiet and distant that we can only imagine their stillness. As you settle under the covers tonight, let yourself drift into that image. A vast cold cloud, silent and timeless, holding within it the first whispers of water. Hydrogen and oxygen finding each other in the dark, coming together to create something that will one day flow in rivers, fall as rain, and soothe you to sleep. You are part of that story, connected by every drop, a reminder that even in the quietest places, the universe is at work, patiently weaving the threads of life. In the deep reaches of interstellar space, far from the warmth of any star, lies a stillness colder than anything you have ever felt. Within that silence, tiny particles of dust drift for millions of years. They are the seeds of worlds, invisible on their own, yet together forming great clouds that stretch across light years. Upon the surfaces of these grains, a slow and delicate transformation begins. Molecules of hydrogen and oxygen, scattered through the darkness, meet and bind to create water. In the near absolute cold, that water does not remain liquid. It freezes instantly, clinging to dust as a thin, glimmering coat of ice. Over unimaginable spans of time, these coatings grow. Layer upon layer builds across the drifting grains until each becomes a frozen speck, carrying within it the memory of stars and the chemistry of life. Though you could never see them with your eyes, telescopes reveal their presence by detecting the faint fingerprints of water ice in the infrared. Astronomers studying these clouds find them rich with frozen particles, so abundant that their combined volume dwarfs the oceans of Earth many times over. The beauty of this process lies in its patience. On Earth, frost forms in a single night, delicate crystals covering windows or grass. In space, the frost accumulates so slowly that entire human civilizations could rise and fall in the time it takes for a single layer to form. Yet the outcome is profound. These icy grains drift together under gravity's pull, colliding gently, sticking, and forming clusters. In this way, the first steps toward planets and comets begin, built upon frozen mantles of water in the dark. Within this ice, more than just water is preserved. Carbon, nitrogen, and simple organic molecules also find their place, locked away in the frozen shells. These tiny carriers hold the potential for chemistry far more complex, and when they eventually join to form larger bodies, they bring these materials with them. Every ocean, every river, every living being may ultimately trace part of its origin to these frozen mantles drifting quietly in the dark. It is strange and humbling to realize that the water around you once endured such a long and hidden stage of existence. Before it filled seas or carved valleys, it may have waited silently as frost on a grain of dust. It may have drifted unseen for millions of years before being pulled into a new star system, where heat and collisions finally released it. That same water is here now, flowing through clouds, rivers, and even your own body, carrying within it the memory of those silent ages. As you drift into rest, imagine that frozen cloud, vast and quiet, filled with grains that shimmer faintly with ice. Each tiny speck is a vessel, carrying not only water but the ingredients of life itself. The stillness of interstellar space is not empty. It is a nursery, storing treasures patiently until the moment they are needed. And the oceans you know today were born in that waiting silence, sculpted first as ice among the stars. Far beyond the planets, in the frozen outskirts of the solar system, drift countless icy bodies that hold within them secrets older than Earth itself. These are comets, fragile wanderers made of ice, rock, and dust, preserved in the cold for billions of years. Each one is a record of the early solar system, untouched since the time planets were forming. To look at a comet is to look back into deep time, to see water and material as they were before Earth became blue. Most of the time they remain hidden, orbiting in the silence of the Kuiper belt or the distant Oort cloud. But when gravity nudges them inward, their story becomes visible. As they draw closer to the sun, their frozen shells awaken. Ice vaporizes, jets of gas burst outward, and they develop glowing tails that stretch across millions of kilometers. For a short while, these objects announce themselves in the sky, carrying with them ancient water that has waited patiently in the dark. Every comet is an archive in motion. Its core holds ice formed in molecular clouds long before the planets existed. Trapped inside are molecules of carbon, nitrogen, and other building blocks of life. When we study comets, we are not only learning about their structure, we are opening a preserved record of conditions from a time when the solar system was still a swirling cloud of dust and gas. Unlike Earth, where geology and biology have erased much of the earliest history, comets have remained almost unchanged. They are messengers from an age we cannot otherwise reach. Scientists believe that during the early bombardment of Earth, comets contributed water to the growing planet. Each collision delivered frozen reserves that vaporized and eventually rained down, helping to fill the basins that became oceans. Whether they supplied most of Earth's water or only a fraction remains a subject of debate, but there is little doubt that they played a role. Their repeated visits across millions of years added to the store of water that allowed our planet to become habitable. To imagine comets is to imagine time itself stored in ice. Picture one of these travelers, a nucleus only a few kilometers across, drifting for billions of years untouched, then suddenly lit by sunlight as it approaches the inner solar system. Its tail glows, its ices release their secrets, and for a brief time it becomes visible to human eyes. Then, just as quickly, it retreats again into the dark, carrying the rest of its archive back into silence. The oceans of Earth may not be entirely cometary in origin, but the contribution of these wanderers cannot be overlooked. They are reminders that water has always been on the move, carried by countless travelers across space, waiting to fall into new worlds. As you let yourself rest, imagine those frozen archives drifting in the dark. Each one contains within it the memory of the early solar system, preserved perfectly in ice. They may seem small against the backdrop of the stars, but they carry the record of beginnings, waiting patiently for the chance to share their story with the worlds they encounter. In the great belt of rock that circles the sun between Mars and Jupiter, fragments of the early solar system still drift. These asteroids are not planets, nor are they lifeless debris as they may first appear. Hidden within their rocky interiors lies something astonishing, a quiet reservoir of water stored not as ice but as part of the minerals themselves. While comets reveal their watery nature in brilliant tales, asteroids keep their secrets locked away in silence, bearing within them a legacy that helped shape our blue world. When the solar system was young, heat from radioactive elements and collisions briefly melted ice within some of these rocky bodies. Water moved through the stone, altering minerals and becoming incorporated into their very structure. What remains today are rocks that look dry and grey but carry hydrogen and oxygen bound at the atomic level. Each asteroid is, in this way, a storehouse of hidden water, preserved for billions of years in forms that are not obvious to the eye. For early Earth, these bodies may have been just as important as comets in delivering water. When asteroids struck, the force of impact shattered their interiors, releasing what was bound inside. Even if no great plume of vapor rose into the sky, the minerals themselves carried water that later became part of Earth's growing reservoirs. Over countless collisions, the contribution added up, until oceans could spread across the planet. The seas we know today may carry within them drops that began their journey trapped deep inside asteroid stone. Unlike comets, which announce themselves with brilliance when they near the sun, asteroids move quietly. Their orbits carry them around the solar system with little fanfare, and yet their role may be just as significant. They are couriers of both water and the chemical precursors of life. Carbon compounds, amino acids, and other organic molecules have been found in fragments that fall to Earth as meteorites, suggesting that asteroids were not only delivering water, but also delivering the seeds of life's chemistry. It is easy to overlook them, to imagine that only the bright streak of a comet could have shaped the destiny of our world. But in truth, the more modest asteroid may have had a longer and steadier influence. While comets came in bursts, striking dramatically, asteroids rained down more consistently, their impacts smaller but more frequent. Their quiet persistence may have provided the steady supply of water that tipped the balance toward a habitable Earth. When your eyes get heavier, picture these rocky travelers moving silently through space. They do not glow, they do not shine, yet within them they carry oceans in waiting, hidden in their minerals. Each one drifts patiently until chance or gravity pulls it inward, guiding it toward a planet where its hidden cargo may be released. You are, in a very real sense, connected to those stones, for the water that moves through you may once have rested inside them. They are reminders that even in the quietest and most unassuming forms, the universe stores its greatest gifts. Envision the world when the night sky stretched above you, scattered with stars so countless they blur into a haze. Each of those stars is a furnace, burning hydrogen, creating heavier elements, and quietly preparing for its final act. Not all stars end gently. Some collapse in spectacular explosions that ripple across the galaxy. These events, called supernovae, are among the most powerful in the universe, and they play a role in something both violent and generous. They are the engines of galactic recycling, the process by which the raw materials for water and for life itself are spread across the Milky Way. When a massive star reaches the end of its fuel, gravity wins the battle it has been fighting for millions of years. The star implodes, its core collapsing in on itself, and in that instant the outer layers are hurled outward at tremendous speed. The explosion is so bright that it can outshine entire galaxies for weeks. In the chaos of that collapse, new elements are forged. Oxygen, essential for the creation of water, is produced in vast amounts and released into the galaxy. Each supernova becomes a delivery of ingredients, scattering the material needed for oceans, rivers, and even the breath you are taking now. The particles created in these explosions do not simply vanish. They drift into interstellar space, joining great clouds of gas and dust. These clouds are the same dark nurseries where hydrogen already waits, patient and abundant. As the shock waves from the supernova pass through, they stir the clouds, mixing the new elements with what was already there. The galaxy becomes a grand cycle, stars creating and then scattering, clouds gathering and then giving birth to new stars. And in that endless rhythm, the materials for water are woven again and again. Scientists can trace this recycling process through the light that reaches us. When astronomers study the remnants of supernovae, they find the fingerprints of oxygen, carbon, and heavier elements. These are the signatures of creation, the marks left by stars that lived, died, and returned their gifts to the galaxy. The very fact that you and I are here is proof of this cycle. The oxygen in your lungs, the calcium in your bones, the iron in your blood, all of it was once part of a star that ended in fire and scattered its remains across space. What is remarkable is how efficient the universe is at reusing itself. Without this recycling, galaxies would run out of the materials needed to form new stars and planets. Instead, every generation of stars enriches the galaxy a little more, adding layers of complexity, making worlds like Earth possible. The water that falls as rain tonight, or that rests quietly in a glass by your bed, carries atoms forged billions of years ago in stars that no longer shine. The explosions that once shook the galaxy have left their traces in something as ordinary and soothing as a sip of water. As you let your eyes grow heavy, imagine the grand cycle continuing even now. Somewhere, a star is reaching its end, preparing to scatter its riches into the cosmos. Somewhere else, a new cloud of gas is collapsing, gathering those materials into the beginnings of new stars, new planets, and new oceans. You are part of that cycle, a collection of atoms drawn together from countless stars, breathing oxygen created in furnaces long extinguished. The universe is not a place of waste but of renewal, a quiet recycling on a galactic scale. And tonight, fully at rest, You carry within you the proof that even in destruction there is creation, and that the water in your body has passed through fire and silence before finding a home in you. Consider a cloud so vast it could swallow thousands of solar systems, yet so diffused that if you were to fly through it, you might not notice the grains of dust brushing past. These are nebulae, enormous swaths of gas and dust drifting through the Milky Way. They appear as faint smudges in telescopes, sometimes glowing where starlight excites their gases, sometimes dark where their density hides the light behind them. Within these clouds, the story of water continues. Here, icy grains gather, layer upon layer, forming the seeds that one day will become planets and oceans. These cosmic clouds are the recycling bins of the universe, filled with the ashes of stars and the raw ingredients for new ones. After supernovae spread oxygen and other elements across the galaxy, those fragments do not remain scattered forever. Gravity begins to draw them together, collecting hydrogen, oxygen, carbon, and dust into dense regions. Over millions of years, these regions cool and condense until they become rich nurseries where chemistry can thrive. The icy grains that build up in these nebulae are not random decorations. They are the first steps toward worlds that can hold seas, rivers, and life. Within these clouds, the conditions are both gentle and extreme. Temperatures are so low that molecules move sluggishly, clinging to dust, grains, and freezing into thin mantles. Yet the sheer size of these clouds means that even the tiniest interactions matter. A single dust grain may collect layer after layer of water ice, carbon dioxide, and simple organic compounds. Multiply that by trillions upon trillions of grains, and the nebula becomes a treasure chest of frozen chemistry. These microscopic seeds drift endlessly until gravity pulls them together into larger structures. Astronomers have looked into these regions with radio and infrared telescopes, searching for the signatures of water and organic molecules. What they find is astonishing. Nebulae contain not just simple ices, but also complex carbon compounds that are precursors to life. These clouds are not empty voids. They are chemical laboratories operating on a galactic scale, preparing the ingredients that one day will be stirred into planets, oceans, and living beings. Every icy grain is a promise, a reminder that the universe is always preparing for the possibility of life, even in its coldest corners. When a cloud grows dense enough, gravity takes over more strongly. Parts of the cloud collapse, forming new stars. Around these stars, disks of gas and dust spin and flatten, filled with icy grains and rocky fragments. Collisions turn grains into pebbles, pebbles into boulders, and eventually into planets. Within that process, the water frozen onto dust grains is carried inward, trapped in rocks, or delivered later by comets and asteroids. Oceans begin with those tiny frozen mantles formed in the dark of the nebula. Every river on Earth, every drop of rain, every tear, traces its story back to those grains of ice drifting in space long before our world existed. If you are still awake, imagine yourself floating in the middle of one of these vast clouds. The stars are hidden, the silence complete, and all around you are countless frozen grains glimmering faintly. Each one carries the potential of oceans, the memory of stars, and the chemistry of life. The nebula may seem like nothing more than a dark smear in the sky, but within it lies the promise of futures not yet born. The age of cosmic clouds is not just a chapter of astronomy. It is a reminder that the seeds of water and life are always present, waiting patiently in the cold, until gravity and time gather them into new worlds. Long before Earth spun itself into being, long before mountains rose or seas filled their basins, water was already traveling through the universe. It drifted as vapor, froze as ice, clung to dust grains, and hid within rocks. It was carried in comets that wandered through the outer reaches of space, stored in asteroids that tumbled quietly in the dark, and scattered by the death throes of stars. Every drop that now trickles down a window pane or laps gently against a shore has its roots in this ancient journey. The water we know today had been moving across billions of years, waiting for a place to gather, waiting for a world to call its home. The first chapter of water's story began almost as soon as the universe itself was born. Hydrogen was created in the first minutes after the Big Bang, and oxygen was forged later inside massive stars. When those stars exploded, they seeded the galaxy with the elements needed for water. Across the Milky Way, clouds of gas and dust thickened with these ingredients, becoming dark nebulae where chemistry could thrive. Within their stillness, molecules of water formed, froze, and clung to grains of dust, turning invisible clouds into archives of ice. Over time, this water found many vessels, some of it coated comets, tiny frozen worlds orbiting far from the sunday. Some of it seeped into the minerals of rocky asteroids, bound tightly to their atomic structures. Some of it drifted loose in vast clouds, thin but abundant. Each form was a resting place, a pause along an endless journey. Though silent and patient, this water was never idle. It was waiting for gravity to pull it into new shapes, for collisions to mix it into newborn solar systems, for a world to form that could cradle it on its surface. When our solar system began to emerge about 4.5 billion years ago, water was already present in every corner. It was part of the swirling cloud of dust and gas that collapsed to form the sun and its planets. It rode within the icy shells of comets, the rocky cores of asteroids, and the frozen mantles of dust grains. Long before Earth cooled enough to hold seas, the ingredients of those seas were already here, circling the young Sunday. Our planet did not create its water from nothing. It gathered what had been traveling for ages, pulling ancient molecules onto its surface and into its rocks. To think of water this way changes how we see it. A glass beside your bed is no longer just a drink, but a vessel filled with cosmic memory. The drop that glistens on your fingertip tonight may have once been frozen onto a dust grain in a dark cloud, or locked away in the heart of an asteroid that circled the sun when it was new. It may have been released in the blaze of a comet's tail, only to be captured again by gravity. And now, after an unimaginable journey, it rests with you, part of your body, part of your world. As you let your eyes close, imagine the water around you not as something ordinary, but as a traveler older than the earth itself. It has crossed silence and fire, cold and distance, time beyond measure. It has waited patiently, moving from star to cloud to comet, until it found this place, this planet, this moment with you. Every drop carries a story billions of years old, a story that began before Earth was born, and tonight it flows quietly through you, as though the universe itself is whispering its history in your veins. Try to imagine standing on the surface of the Earth in its earliest days, though of course no human eyes were there to see it. What you would find is not the familiar blue planet with seas and skies, but a world of fire. The ground itself was molten, a restless sea of lava stretching as far as vision could reach. Volcanoes erupted constantly, spilling rivers of magma, while the air shimmered with heat so intense that even rocks could not hold their form for long. This was a world without oceans, without rivers, without rain. Water could not survive here, at least not in the liquid form that would one day cradle life. The Earth was born from collisions, countless fragments of rock and metal smashing together under gravity's pull. Each impact released enormous energy, enough to melt whole regions of the growing planet. The surface was not a stable crust, but a restless ocean of molten stone, churning and glowing with heat. Above it, the atmosphere was heavy with gases released from the interior, thick with carbon dioxide, nitrogen, and sulfur compounds. The pressure was immense, the temperature unbearable, and in this early chaos there was no place for liquid water to pool or flow. If a comet or asteroid carrying ice had struck Earth during this time, its water would not have lingered. The intense heat of the surface and sky would have vaporized it instantly, turning ice to steam that escaped back into space. The young Earth could not yet hold on to the gift of water. Instead, the molecules that would one day fill oceans remained locked in minerals deep within the planet, or drifted in space, waiting for a more welcoming time. The skies above this fiery surface were not blue, but dark and red, thick with dust and smoke. The sun, weaker in its youth, cast a pale light that was filtered through choking clouds. Lightning may have cracked across the skies, striking volcanic plumes, but no thunderstorm would have followed, for there was no rain to fall. It was a world restless with energy, yet barren of the calm pools and rivers we associate with Earth. Over time, as the violence of formation slowed, The earth began to cool. The molten surface gradually hardened into a crust, though even then it was fragile and easily broken by new impacts. Beneath the crust, heat still boiled, and volcanoes erupted constantly, releasing gases from the planet's interior. Among those gases was water vapor, carried upward from deep inside the earth. Slowly, the atmosphere thickened with it, yet even then, liquid water could not settle. The surface remained too hot, the air too heavy. Steam rose and lingered, but lakes and seas had not yet formed. When we think of oceans today, we picture the blue that defines our planet from space. We imagine waves crashing against shores, clouds rising from their surfaces, rain falling back again in endless cycles. But in this earliest time, that cycle did not exist. The Earth was a place of extremes, its face scarred by fire and impact, its sky heavy with heat. Water existed only in potential, hidden within rock, or waiting in icy bodies that orbited beyond. Tonight, imagine that barren Earth, glowing red under a hazy sky. It seems inhospitable, lifeless, unrecognizable compared to the world you know. And yet, it was only a stage in the longer story, a beginning that set the conditions for change. The oceans were not yet here, but their ingredients were already near, waiting for the planet to cool, waiting for the right balance of temperature and atmosphere. What looks like emptiness in that fiery world was in truth preparation. The water you drink, the seas you sail, the rain that falls softly outside your window, all were already part of the story, waiting for their moment to appear. Imagine the Earth after its fiery youth, when oceans of molten rock stretched across its surface and the air was filled with choking heat. Over time, the violence of constant collisions slowed. Fewer massive bodies slammed into the planet, and the energy from those earlier impacts began to dissipate. Slowly, the restless surface began to change. Lava cooled, hardened, and cracked, forming the first fragile crust. It was thin and unstable, broken again and again by eruptions and impacts, yet it marked the beginning of a transformation. The chaos of a molten world was giving way to a planet that could one day hold seas and life. As the crust thickened, it acted like a shield, separating the fiery interior from the cooling surface. Volcanoes still erupted, sending rivers of lava spilling outward, but not everything melted again. For the first time, there were stretches of solid ground, jagged and black, rising above the heat. These early rocks became the foundation of continents yet to come. Though they looked nothing like the landscapes we know now, they were barren, lifeless, and surrounded by a thick atmosphere heavy with gases. Still, they represented stability, the first step toward a planet where water could rest on the surface instead of escaping into space. The air above this cooling crust was filled with volcanic emissions. Carbon dioxide and nitrogen dominated, along with sulfur and methane. But most importantly, water vapor was pouring out of the Earth's interior, carried upward by eruptions. This vapor gathered in the atmosphere, too hot to condense, but present in staggering amounts. For millions of years it lingered as steam, forming thick clouds that trapped heat and kept the surface sweltering. Yet as time passed, the planet radiated more energy away into space, and the crust continued to harden. Gradually, temperatures dropped. The upper layers of the atmosphere cooled, and the thick steam that had circled the globe began to condense. For the first time, droplets formed and fell. At first they evaporated before touching the ground, but as the cooling continued, rain began to strike the rocky crust. Imagine the sound of it, falling on stone that had never known water, hissing and steaming as it touched still warm surfaces. Over time, the rain became heavier and more persistent, shaping the bare rock, pooling in low places, beginning the long process of carving valleys and filling basins. This period, often called the Great Cooling, was more than a geological shift. It was a turning point in Earth's history. Without a crust to protect the surface, water could never have lingered. Without volcanic gases, there would have been no atmosphere to hold the vapor long enough to condense. The balance of heat and cooling, of rock and sky, created the first true conditions where water could remain on Earth. And with water came the possibility of oceans, rivers, and eventually life itself. It is humbling to think that every raindrop today, every stream and wave, depends on that ancient transition. The crust beneath your feet, the ground that feels so solid and permanent, was once molten. It solidified slowly, layer by layer, until the surface could hold not only rock but water, and that water, patient and persistent, transformed everything that followed. Lying to rest, imagine that shift, from glowing lava to dark rock, from steaming vapor to the first rains. Picture a world cooling under heavy clouds, its face changing from fire to stone. In that transformation, the stage was set for the blue planet you know today. The chaos did not vanish, but it softened, creating space for water to arrive and stay. And in that space, the story of Earth's oceans began. Picture for a moment the young Earth, still scarred from its fiery beginnings, its surface cooling but its skies heavy with steam and gas. Rain had begun to fall, yet the oceans we know today were not fully formed. Scientists have long wondered where all that water came from, enough to cover most of the planet and to create the seas that cradle life. One of the most captivating ideas is that much of it arrived from afar, carried by icy wanderers that crossed the void and struck the Earth with their frozen cargo. This is the comet hypothesis, the vision of water delivered across space by visitors that burned brightly as they fell toward the Sunday. Comets are ancient bodies, mixtures of rock, dust, and ice, preserved in the outer reaches of the solar system. For billions of years they orbit silently in the cold, far beyond the planets, stored in vast reservoirs like the Kuiper Belt and the Oort cloud. Occasionally, a shift in gravity nudges one inward, pulling it onto a path that leads past the planets and close to the Sunday. As the comet approaches, sunlight warms its surface and releases jets of vapor, creating the luminous tails we see in the night sky. Inside that glow lies something precious, water that has remained frozen since the dawn of the solar system. If comets carried water, and if they collided with the young Earth often enough, they could have contributed significantly to our oceans. Each impact would have released water vapor into the atmosphere, which later condensed and fell as rain. Over millions of years, these deliveries could have built vast seas. Imagine the skies of the early Earth streaked with fiery trails as comets plunged through the atmosphere. Each one exploded with tremendous force, but also with a gift. Within their destruction, they seeded the planet with water, drop by frozen drop. The idea has fascinated scientists for decades, and missions into space have tested it. In 2014, the Rosetta spacecraft orbited Comet 67P and measured the composition of its water. What it found was intriguing. The ratio of hydrogen to deuterium, a heavier form of hydrogen, was different from what we see in Earth's oceans. This suggested that not all of our water could have come from comets like that one. Some scientists proposed that asteroids, which also carry water in their minerals, may have played a larger role. Yet the mystery remains. Other comets, perhaps from different regions of the solar system, may carry water closer in composition to our own. What matters most is that comets preserve water in its oldest form, unchanged for billions of years. Studying them is like reading a page of history that has not faded. They show us what water was like when the solar system was young, before Earth had cooled, before oceans had spread across its surface. Whether they delivered all, some, or only a little of our water, they remain messengers from a time we cannot otherwise touch. As you close your eyes, imagine those icy wanderers moving slowly through the dark, waiting for gravity to tug them inward. Picture their tails glowing as they pass the sun, their frozen interiors releasing vapor that stretches for millions of kilometers. Then imagine one of them falling toward Earth, breaking apart in the sky, and scattering water across a barren surface. Each comet is a vessel of memory, carrying water older than Earth, releasing it to a world that was learning to become blue. Whether they gave us most of our oceans or only a fraction, their story is woven into every drop you drink tonight. Envision the early Earth under constant bombardment, its young crust cooling but still restless, its skies thick with clouds of steam. Across millions of years, countless objects fell from space, each one carrying material left over from the birth of the solar system. Some of those objects were asteroids, rocky bodies that seemed dry and barren on the outside, yet deep within them they carried something extraordinary. Locked into their minerals was water, hidden not as ice or vapor but bound tightly within the very structure of the rock. When those asteroids struck Earth, they released their hidden cargo, drop by drop, adding to the oceans that were just beginning to form. Scientists discovered the clues to this hidden water not in space, but in meteorites that landed on Earth. These fragments, survivors of ancient collisions, hold within them hydrated minerals, crystals that include water in their atomic bonds. By analyzing these meteorites, researchers realized that asteroids were not simply dry rubble. They were carriers of water, vessels that had preserved it for billions of years. When these bodies crashed into Earth, the heat of impact broke apart the minerals and released the water trapped inside, a hidden source of oceans flowing quietly from stone. Unlike comets, which release visible vapor as they near the sun, asteroids keep their secrets locked within. From a distance they appear lifeless, grey, and unremarkable, yet appearances deceive. The hydrated minerals reveal that liquid water once moved through them, perhaps inside their parent bodies. Long ago, ice melted briefly under heat from radioactive decay or from collisions, seeping through cracks and altering the rock. That brief presence of liquid water left its mark, creating the hydrated minerals we see today. The very existence of those minerals tells us that water was there, quietly shaping even the smallest worlds. Modern missions have confirmed this story. When spacecraft visited asteroids like Bennu and Ryugu, they found undeniable evidence of hydrated minerals. Samples collected and brought back to Earth are expected to reveal even more detail, giving us a clearer picture of how much water these asteroids carry. The evidence suggests that impacts from such bodies were not rare events. In the chaotic early solar system, collisions were constant. With each strike, the Earth received more water, slowly building the reservoirs that would one day become seas. The thought that oceans may have come from stone is deeply humbling. We often imagine water as something fragile, melting, flowing, vanishing into vapor. But here it was hidden in the hardest of places, locked within minerals for eons, only to be freed by the violence of impact. Each asteroid was a messenger, delivering not only water but also organic molecules, the raw materials of life. In their destruction, they offered creation, contributing to the conditions that would make Earth habitable. With your eyes closed, picture an asteroid drifting silently through space, its rocky surface cold and dark. Inside, unseen, water waits patiently, carried across billions of kilometers. Gravity pulls it inward, drawing it closer to Earth, until it finally strikes. In the instant of impact, heat and pressure shatter the rock and release its hidden water, adding to pools and rivers yet to form. The ocean you know today may carry within it drops that were once bound inside such stones. Every wave, every raindrop, carries echoes of those hidden deliveries. The seas did not simply appear. They were built piece by piece, gift by gift, from the rocks that fell out of the dark and released their liquid secrets to a waiting world. Deep within the Earth, long before the surface cooled into something familiar, reservoirs of molten rock churned and shifted. From those fiery depths, gases began to rise. They carried with them water bound in minerals, released under heat and pressure, finding their way upward through fractures and vents. When they reached the surface, they escaped in bursts of steam, invisible rivers of vapor spilling into the young sky. It was not rain yet, nor ocean, but a slow exhalation of the planet itself, breathing out its hidden reserves. In those early days, Earth's surface was raw and unstable. Volcanoes were not isolated peaks but vast fields of eruptions, stretching across continents that had not yet fully formed. Each eruption did more than pour out lava. It released a mixture of gases, carbon dioxide, nitrogen, sulfur compounds, and above all, water vapor. The atmosphere thickened with these emissions, gradually forming a blanket that held warmth, kept pressure, and began to change the conditions above the searing crust. Water rising from the interior in this way may seem strange, but it is a natural result of how the Earth was built. The minerals that made up the young planet trapped hydrogen and oxygen within them. When heated, they released this water, drop by drop, molecule by molecule, until the sky became heavy with vapor. This process took millions of years, yet it was relentless. With each outpouring, the atmosphere grew wetter, preparing the way for rain that would one day fall in torrents. Unlike the sudden impacts of comets or asteroids, volcanic outgassing was steady. It did not arrive in bursts but continued across ages, a background rhythm to the early chaos. It was as if the planet itself was exhaling, steadily filling the air with what would soon become seas. Without this contribution, Earth might have remained barren, a world with no rivers to carve valleys and no oceans to cradle life. The volcanic landscape itself was shaped by this breath. Rivers of molten rock cooled into basalt, fractured by steam explosions that cracked the surface. Around vents, new minerals formed as vapor condensed and reacted, leaving behind crystalline traces of the chemistry at work. These places were harsh and dangerous, yet they were also cradles of transformation, where Earth's hidden water shifted from stone to sky. Even today, volcanoes remind us of this ancient role. When they erupt, plumes of steam rise high into the atmosphere, echoing the processes that shaped the world long ago. The difference is that now the oceans already exist, vast and enduring. But in those early times, every plume was a contribution to a world still in the making. As you drift into rest, imagine that young Earth breathing, not with lungs but with mountains and molten fields. Each exhalation carried water upward, turning rock into vapor and vapor into sky. You are connected to that ancient breath, for the water that surrounds you and moves through you once rose in those plumes. Long before it fell as rain or filled the oceans, it was carried on the breath of a restless planet, rising from the depths to shape the world we call home. Think about holding a glass of water and realizing that its origin is still a mystery. We know that hydrogen and oxygen formed long before Earth. We know that comets and asteroids carried water through space. And we know that volcanoes exhaled steam from the planet's interior. Yet how much of the water around us came from each of these sources remains an unsolved puzzle. The seas that cover our world are ancient, but the story of how they arrived is still being pieced together, one clue at a time, through meteorites, spacecraft, and the chemistry of raindrops. For decades, scientists believed comets might have been the main carriers. Their icy bodies, preserved in the cold outskirts of the solar system, seemed like obvious candidates. If enough of them struck the young Earth, their water could have filled the oceans. But when missions like Rosetta studied the composition of cometary water, the results told a more complicated story. The ratio of hydrogen to its heavier isotope deuterium was not the same as what we find in Earth's seas. This suggested that not all of our water came from comets. They may have added some, but they could not be the only source. Attention then turned to asteroids. Unlike comets, they do not appear icy, yet many are rich in hydrated minerals, rocks that carry water within their structures. Samples of meteorites that landed on Earth revealed water with a chemical fingerprint closer to our own. This pointed to asteroids as important contributors, perhaps even the primary ones. The idea that oceans could have come from stone rather than ice reshaped our understanding. Impacts from water-rich asteroids may have steadily delivered enough to cover the Earth's surface. Yet another source lies closer to home. Deep within the mantle, minerals hold hydrogen and oxygen that can be released as vapor through volcanic eruptions. Outgassing would have filled the atmosphere of the young Earth with steam, which eventually condensed as rain. This process could have built oceans without needing comets or asteroids at all. Some researchers argue that most of Earth's water was present from the very beginning, trapped in its rocks when the planet formed, then brought to the surface over time. The truth may be a combination of all these sources. Earth's water might be a mosaic, stitched together from contributions across space and from within. Comets could have added some, asteroids more, and volcanic outgassing could have supplied the rest. The challenge lies in measuring and comparing isotopes, in analyzing samples from faraway bodies, and in recreating the violent conditions of early Earth. Each experiment brings us closer, but no single explanation has yet solved the puzzle completely. This uncertainty is not failure, but part of the wonder. Water's story mirrors the complexity of the cosmos, It does not offer us one neat answer, but a tapestry woven from many threads. That glass you hold might contain molecules that once froze onto dust grains in interstellar clouds, others that were locked in rock for billions of years, and others that rose from the deep breath of Earth itself. To drink it is to taste not one origin, but many. As you rest tonight, consider how extraordinary it is that such an ordinary substance carries such mystery. Oceans stretch across the planet, rivers flow constantly, rain falls with regular rhythm, and yet the exact origins of this abundance are still being unraveled. The answer may never be a single line, but a blend of many sources, a story told through collisions, eruptions, and cosmic chemistry. Let that thought settle quietly with you, that every drop is a mixture of journeys, a solution to a puzzle still unsolved, and a reminder that even the most familiar things can hold secrets as deep as the stars. Picture the young Earth, still scarred from its fiery beginnings, its surface cooling but its skies heavy with steam and gas. Rain had begun to fall, yet the oceans we know today were not fully formed. Scientists have long wondered where all that water came from, enough to cover most of the planet and to create the seas that cradle life. One of the most captivating ideas is that much of it arrived from afar, carried by icy wanderers that crossed the void and struck the Earth with their frozen cargo. This is the comet hypothesis, the vision of water delivered across space by visitors that burned brightly as they fell toward the sunday. Comets are ancient bodies, mixtures of rock, dust, and ice, preserved in the outer reaches of the solar system. For billions of years they orbit silently in the cold, far beyond the planets, stored in vast reservoirs like the Kuiper Belt and the Oort cloud. Occasionally, a shift in gravity nudges one inward, pulling it onto a path that leads past the planets and close to the sunday. As the comet approaches, sunlight warms its surface and releases jets of vapor, creating the luminous tails we see in the night sky. Inside that glow lies something precious, water that has remained frozen since the dawn of the solar system. If comets carried water, and if they collided with the young Earth often enough, they could have contributed significantly to our oceans. Each impact would have released water vapor into the atmosphere, which later condensed and fell as rain. Over millions of years, these deliveries could have built vast seas. Imagine the skies of the early Earth streaked with fiery trails as comets plunged through the atmosphere. Each one exploded with tremendous force, but also with a gift. Within their destruction, they seeded the planet with water, drop by frozen drop. The idea has fascinated scientists for decades, and missions into space have tested it. In 2014, the Rosetta spacecraft orbited comet 67P and measured the composition of its water. What it found was intriguing. The ratio of hydrogen to deuterium, a heavier form of hydrogen, was different from what we see in Earth's oceans. This suggested that not all of our water could have come from comets like that one. Some scientists proposed that asteroids, which also carry water in their minerals, may have played a larger role. Yet the mystery remains. Other comets, perhaps from different regions of the solar system, may carry water closer in composition to our own. What matters most is that comets preserve water in its oldest form, unchanged for billions of years. Studying them is like reading a page of history that has not faded. They show us what water was like when the solar system was young, before Earth had cooled, before oceans had spread across its surface. Whether they delivered all, some, or only a little of our water, they remain messengers from a time we cannot otherwise touch. As you close your eyes, imagine those icy wanderers moving slowly through the dark, waiting for gravity to tug them inward. Picture their tails glowing as they pass the sun, their frozen interiors releasing vapor that stretches for millions of kilometers. Then imagine one of them falling toward Earth, breaking apart in the sky, and scattering water across a barren surface. Each comet is a vessel of memory, carrying water older than Earth, releasing it to a world that was learning to become blue. Whether they gave us most of our oceans or only a fraction, their story is woven into every drop you drink tonight. Once the rains had fallen, once the floods had spread across the land, the next transformation began. Water that had gathered in valleys and craters did not vanish. It lingered, joined together, and grew. Streams merged into rivers, rivers into lakes, and lakes into basins so vast they became the first oceans. What had been scattered droplets and temporary floods now stretched into expanses that reshaped the face of the planet. The oceans did not appear in a single moment. They grew through countless contributions, drop by drop, delivery by delivery. Some of the water came from the sky, falling as rain from an atmosphere heavy with vapor. Some of it rose from the planet itself, carried upward in volcanic plumes before condensing and settling back down. Some was delivered by asteroids and comets, their icy cargo vaporized upon impact, then falling again as precipitation. From many sources, across millions of years, the waters collected and endured. As they spread, the oceans began to sculpt the surface. They wore down mountains, carried minerals across continents, and carved coastlines that shifted as waters rose. Sediment carried by rivers settled on the ocean floor, creating layers that recorded the earliest history of Earth's surface. The constant movement of tides and currents began to shape not only land but climate. Heat was absorbed, redistributed, and released, creating patterns that softened extremes and allowed the planet to stabilize. The oceans also changed the appearance of Earth itself. From space, what had been a glowing sphere of rock and fire now gleamed blue. The seas covered most of the surface, reflecting sunlight and altering the balance of energy the planet received. Clouds formed more regularly as evaporation fed the skies, completing the first cycles of weather as we know them. The world had entered a new identity, no longer only rock and air, but rock, air, and water intertwined. These new oceans were restless. They boiled and surged under the heat of a young sun, stirred by volcanic activity still reshaping the crust beneath. Waves broke against new coastlines, reshaping them again and again. In the depths, chemical reactions between water and rock released minerals, enriching the seas with elements that would later become essential for life. Though no living thing yet swam in them, the stage was being prepared. The oceans were not passive mirrors of the sky. They were engines, mixing heat, chemistry, and motion, turning Earth into a dynamic world. Over time, the waters reached an equilibrium, filling basins and spreading across the globe until vast stretches of blue defined the planet. Continents emerged here and there, but water dominated. The balance had tipped. Earth had become a water world, unique in the solar system. As you drift tonight, imagine those first oceans spreading outward, swelling into great bodies that covered the land. Picture the waves rolling endlessly, carrying with them minerals, energy, and the promise of life. The water that surrounds us now began then, in the merging of rains, rocks, and icy gifts, flowing together until the Earth was transformed into the blue planet we know. For millions of years, the Earth had been a place of fire, its surface shaped by molten rock, collisions, and storms of gas. Then water arrived in strength, spreading across the basins, filling valleys, and rising until oceans covered most of the globe. In that moment, the planet transformed. No longer only grey and red with stone and fire, it became a world of blue. The seas reflected the light of the young sun, and the Earth's identity changed forever. From space, had there been eyes to see it, the transformation would have been unmistakable. The surface now gleamed with oceans, vast enough to dominate the face of the planet. Clouds traced white patterns above the water, swirling endlessly as evaporation joined sky to sea. Continents were small interruptions in the expanse, scattered fragments compared to the deep, unbroken stretches of blue. For the first time, Earth looked like itself, a water world, luminous against the blackness of space. The oceans did more than cover the land. They gave the planet its rhythm. Tides pulled by the moon stirred the waters, sending currents flowing around the globe. Winds interacted with the surface, carrying moisture inland, shaping climates, and feeding rivers. Storms rose and fell above the seas, balancing heat and energy. The blue was not just a color, it was a living system, always in motion, always shaping the conditions of the world. This transformation marked a turning point. Water now dominated the geology as much as rock and fire had before. Coastlines shifted with erosion, cliffs crumbled, and mountains wore down as waves crashed against them. Sediments carried into the oceans settled on the seafloor, burying the record of change layer by layer. The chemistry of the seas began to interact with the atmosphere, dissolving gases, moderating temperatures, and stabilizing conditions for what would one day be life. To call Earth the blue planet is more than description. It is recognition of how water has defined its character. In the solar system, other worlds hold traces of ice or ancient riverbeds, but only Earth became a world where liquid water stretched unbroken across its surface. The color we see from orbit is not an accident. It is the signature of abundance, a reflection of oceans deep enough to fill trenches miles below the surface, broad enough to cover continents, and enduring enough to last for billions of years. As you picture the planet tonight, imagine it from the perspective of the stars, turning slowly, its oceans catching sunlight and scattering it back into space. Earth became blue because water had come to stay. That transformation still defines it, still marks it as different from the barren or frozen worlds nearby. The blue planet emerged when water claimed its place, and every wave and cloud since then has been part of that continuing story. Imagine the Earth after its transformation into a blue planet, the oceans vast and restless under heavy skies. They stretched across most of the surface, waves rising and falling endlessly, their depths dark and mysterious. The land was bare rock, volcanic and lifeless, but the seas carried something more. Within their waters, the chemistry of the universe was at work, molecules colliding, breaking apart, and combining again in a ceaseless dance. It was here, in this shifting and swirling cradle, that the first sparks of life began to appear. The oceans were not calm, gentle places in those early days. They were filled with dissolved minerals carried by relentless rain and delivered by volcanic eruptions. Hydrothermal vents on the ocean floor released heat and chemicals, creating pockets of energy in the deep. Sunlight filtered into the shallows, where it stirred reactions among the molecules drifting there. Everywhere in the seas, conditions were set for something remarkable to happen. Out of simple compounds, complexity began to form. At first it was only chemistry, chains of carbon and nitrogen coming together, small structures built from the raw materials that filled the oceans. But with time, those structures grew more elaborate. Some began to copy themselves, a first step toward persistence. Once that happened, the boundary between chemistry and life blurred. What began as random reactions became organized, and what was organized found ways to endure. Life, fragile and simple, had arrived. These first living things were nothing like what we know today. They had no shells, no bones, no eyes to see or fins to swim. They were tiny, microscopic, existing as little more than membranes that enclosed fragile molecules. Yet in their simplicity, they carried the most important property of all, the ability to replicate, to pass on their form, to survive long enough to give rise to generations. From these beginnings, the story of every plant, every animal, every person would eventually unfold. Water was essential at every step. It dissolved minerals and nutrients, making them available for reactions. It stabilized fragile molecules, protecting them from breaking apart too quickly. It provided a medium where molecules could drift and meet, where chance encounters could become lasting bonds. Without water, the reactions would have been scattered and isolated. In the oceans, they were concentrated, nurtured, and given the space to evolve. The seas became laboratories on a planetary scale, running experiments endlessly until something new and enduring appeared. Even now, life clings to water. Every cell in your body carries the memory of its origins, filled with fluid that echoes the chemistry of the ancient oceans. When you drink a glass of water, you are not just quenching thirst, you are partaking in the very substance that made life possible. The oceans gave that gift billions of years ago, and it has never been taken back. It is almost impossible to imagine how long this process took. Millions of years passed while molecules drifted, collided, and changed. The first life was not a sudden event, but a gradual emergence, a slow unfurling of possibility. Yet once it appeared, it could not be undone. Life became a new property of Earth, inseparable from the water that sustained it. Half sleepy by now, picture those ancient seas, restless and alive with hidden chemistry. Imagine molecules swirling in the depths, some breaking apart, others finding shapes that allowed them to last. Then imagine the first fragile life, so small it could not be seen, yet carrying within it the potential for all that followed. Water was the gift, the medium, the cradle. From it came life's first breath, whispered softly in the dark of the ocean, setting in motion the story that includes you tonight. Think of water not as something still and ordinary, but as a traveler moving endlessly through time. It has flowed across billions of years, shifting its form from vapor to ice to liquid, yet always remaining the same in essence. The water that moves through your body tonight is not new. Its atoms were forged in the early universe, combined in the quiet dark of molecular clouds, frozen onto dust grains, and carried by comets and asteroids. It has drifted through interstellar space, fallen as rain on newborn Earth, filled oceans, and passed through living things countless times. Every drop is ancient, yet every drop feels fresh, as if it has just arrived. To follow water's journey is to follow a thread that ties together the entire history of our planet. It flowed as vapor in the skies of the young Earth, condensed into raindrops, and fell in torrents that filled the first seas. It surged through rivers, carved into new rock, evaporated into clouds, and fell again as rain. The cycle never ceased. Oceans rose and receded, glaciers formed and melted, lakes appeared and vanished. Yet the water remained. It moved, but it did not disappear. It was recycled endlessly, traveling without pause through eons. Consider that a single molecule of water might once have been part of an ancient ocean where the first life stirred. Later it could have been locked in ice during a global freeze, only to melt and return to the sea. It may have been part of the drink of a dinosaur, or fallen as rain on a forest that no longer exists. It may have risen in the mist of a waterfall, or frozen into a snowflake that drifted quietly to the ground. Tonight it might be in the glass beside your bed, ready to become part of you. Its journey never ends, and it carries with it the memory of every stage it has passed through. Water is unchanged in its essence, yet transformed constantly in form. It is the same molecule whether it drifts unseen as vapor, crashes in waves against a shore, or rests still in a frozen glacier. Its persistence gives it a timeless quality, as if it were less a substance and more a rhythm that the earth itself keeps. The rivers we see today echo rivers long gone, the clouds overhead mirror clouds that floated above the first continents. To touch water is to touch something that has been here since before our world, something that will remain long after we are gone. As you close your eyes, imagine a river that does not begin or end, but flows endlessly through the ages. Its current carries with it the story of stars, planets, and life. Each drop in that river is both ancient and new, both a traveler and a witness. The water in you tonight is part of that river, moving quietly through your veins before returning to the world. It has always been here, and it always will be, a constant presence in the shifting fabric of time. Imagine holding a glass of water and realizing that what you see shimmering there is not new. The drops you drink today are the same drops that once moved through the bodies of creatures long vanished, creatures that roamed the earth in an age of giants. When dinosaurs walked across ancient forests, when their massive forms bent down to drink from rivers and lakes, they sipped from the same water that now flows through your veins. The molecules have traveled through time unchanged, endlessly recycled, moving from rain to river to ocean to cloud, nourishing life across eons. The cycle of water ensures that nothing is ever lost. When a dinosaur drank from a stream, much of that water became part of its body, carried through its blood, fueling its cells. Later it left as breath, as sweat, or as waste, returning to the world. Some evaporated into the air, condensed into clouds, and fell again as rain. Some soaked into the soil, filtered through stone, and re-emerged in springs. Some traveled to the ocean, joining waves that crashed against shores lined with strange, ancient plants. The creatures are gone, but the water remains, moving ceaselessly through time. Imagine a towering sauropod lowering its long neck to sip from a lake, or a fierce predator pausing to lap water from a riverbank. The same molecules touch their tongues that might touch yours tonight. The thought shrinks time, connecting your present to a past that feels unimaginably distant. The water that fills your glass may once have cooled the skin of a triceratops or washed over the eggs of a pterosaur in a muddy nest. It may have been part of a swamp where dragonflies with wings like dinner plates hovered above the surface. This connection is not limited to dinosaurs. Every form of life has shared in this flow. Fish in ancient seas swam through it, amphibians crawled out of it, mammals sipped it as they emerged in the shadows of reptiles. Trees pulled it through their roots, releasing it back into the air through their leaves. Even the earliest cells floated in it, finding safety and nourishment in its embrace. Water is the thread that has bound every living thing, weaving their stories together across time. What makes this even more extraordinary is the constancy of water's essence. Though it takes many forms, vapor in the sky, ice in a glacier, liquid in a river, it is always the same substance. It does not age, it does not fade. The very drops that once trickled down the leaves of prehistoric plants may now fall as rain in your city, or gather as dew on your window. The molecules remain, endlessly rearranged, but never destroyed. As you lie here tonight, imagine lifting your glass again and seeing not just clear liquid, but a reflection of deep time. With every sip you taste the history of the earth. You drink what once sustained the giants of the past, what once rippled through jungles long gone, what once rose as mist from ancient seas. In every swallow is a connection to that distant world, a reminder that life today is linked to life that came before. The dinosaurs may be gone, but the water that nourished them is still here, flowing quietly through you, part of a cycle as old as the earth itself. Look up at the sky on any given day, and you will see clouds drifting gently, changing shape, building and dissolving as if they were only passing decorations. Yet the truth is far deeper. The clouds above you carry water that has risen and fallen countless times, a cycle older than civilizations, older than cities, and even older than the earliest stories told by human voices. Each drop within them has been part of an endless journey, evaporating from seas, condensing into vapor, and returning again as rain or snow. What you see in a cloud today is part of a system that has been in motion since the first oceans formed billions of years ago. Envision the first humans looking at the sky. They must have wondered what these shifting white forms meant, why they brought storms and rain, why they appeared and disappeared without warning. Long before writing, clouds were symbols, woven into myths and carried in oral traditions. They became signs of gods, omens of fertility, and warnings of floods. Yet behind the mystery was the same simple process we understand now: water rising in vapor and cooling into droplets too small to fall, suspended in the air until they gathered enough weight to descend again. Civilizations were built beneath these cycles, their crops watered by rains, their rivers fed by melting snows, their lives dependent on the rhythm of clouds. Every empire, every ancient village, every wandering tribe lived under skies filled with the same recycled water that you see today. The clouds over Mesopotamia that watered the first fields, the storms over Egypt that swelled the Nile, the monsoons that nourished India and China, all carried water that had risen countless times before and would fall countless times again. The people who looked up did not know that the drops falling on their faces might once have fallen on a prehistoric forest or been locked in a glacier. They only knew that life depended on the return of rain. The timelessness of clouds lies in their constant renewal. They are never the same, yet they are always familiar. A drop that leaves the sea may drift for days before falling as a storm hundreds of miles away. Another may freeze into snow and rest in a mountain glacier for centuries before melting back into a stream. Yet all of it returns to the air, eventually, rising to form new clouds. No matter how many times the cycle repeats, the essence of water remains unchanged. What is remarkable is how personal this becomes when you realize that the clouds above you tonight carry molecules that once floated above the heads of people thousands of years ago. The same vapor that nourished crops in the Fertile Crescent, that washed over Roman rooftops, that fed the rivers beside ancient temples, is still here, reshaped into the clouds of today. Civilizations have risen and fallen, but the water in the sky has endured, patiently recycling itself through time. As you let your eyes close, picture those clouds not as temporary patterns, but as travelers older than history. They drift above the earth as they always have, silent and steady, carrying water from sea to sky and back again. Each cloud you see is part of a cycle that has never ended, connecting you with every life that came before. Tonight, the same drops that once fell on ancient fields may fall outside your window, reminding you that water is not only life, it is memory, carried endlessly in the sky. Imagine standing before a glacier, its surface shining pale blue under the light, its body stretching back into valleys and mountains like a frozen river. What you see is not just ice, but memory, layer upon layer pressed together over thousands of years. Each flake of snow that fell was once a cloud, once vapor rising from seas and lakes. Over time, those flakes compacted, forming solid ice that holds within it tiny bubbles of air, dust, and particles. Trapped in those layers is a record of Earth's past, a story of climates long gone, preserved more faithfully than any book or monument. Glaciers and polar caps are often called frozen archives. Scientists drill deep into their cores, extracting cylinders of ice that can reach back hundreds of thousands of years. Within these samples, they find more than frozen water. They find records of ancient atmospheres, tiny bubbles that still hold the air once breathed by mammoths and early humans. They find evidence of volcanic eruptions, carried as ash and sealed into ice. They even detect traces of changes in temperature and precipitation, written in the thickness and composition of the layers. To read an ice core is to travel back in time, 1 year at a time, through the slow accumulation of frozen memory. These icy archives tell us of warm ages when glaciers retreated, and of bitterly cold times when ice advanced across continents. They reveal how carbon dioxide has risen and fallen through natural cycles, and how abruptly the planet can shift from one state to another. In this way, ice becomes not just a passive presence, but a storyteller, whispering the history of Earth's climates. Unlike stone, which erases its past through erosion, or forests, which live and die in shorter spans, ice preserves detail in delicate precision, keeping even the smallest signals intact for millennia. The polar caps themselves are even grander in scale. Antarctica and Greenland hold ice sheets so thick that they contain most of the fresh water on the planet. Buried deep within their frozen layers are records stretching back millions of years. Every snowfall, no matter how small, has added to the record, compressing slowly into history. To walk across these landscapes is to walk upon pages of time stacked endlessly beneath your feet, silent and cold, but rich with information. Ice does not only preserve, it also reflects. The brightness of glaciers and polar caps bounces sunlight back into space, cooling the planet and regulating climate. When they grow, the Earth cools. When they shrink, the Earth warms. In this way, ice is not only a memory but also a participant, a force shaping the present, even as it records the past. It is both archive and actor, preserving history while influencing what comes next. As your breathing slows, imagine those ancient glaciers, patient and enduring, holding within them the stories of the Earth. Picture each flake of snow falling softly, joining countless others, compressing into layers that will last for ages. Somewhere inside that ice is air from a world without cities, water frozen when great beasts still walked the land, a memory of times you can only imagine. In every frozen layer, the planet has kept a journal, and though it is silent, it speaks to those who listen. The glaciers are memory made visible, frozen rivers of time carrying the story of Earth across the ages. Picture a single tear forming in the corner of your eye, a drop so small it seems insignificant, yet within it lies the same essence as the waves that crash against distant shores. The water that moves quietly through your body is the same water that fills oceans, lakes, and rivers. It has flowed across time, transformed but unchanged, cycling between clouds, rain, rivers, and living beings. When you shed a tear, you are not only expressing emotion, you are participating in a cycle as old as Earth itself. Your body is a vessel shaped by water, and through it you are linked to seas stretching far beyond the horizon. More than half of your body is made of water. It cushions your cells, carries nutrients, regulates temperature, and allows every process of life to unfold. Without it, you could not think, breathe, or move. This same water was once part of rainfall that carved valleys, part of glaciers that sculpted mountains, part of oceans that rocked in rhythm with the pull of the moon. Within you flows the same substance that once nourished forests where dinosaurs roamed, and that now laps gently against modern shores. Your tears and the seas are made of the same drops, endlessly shared, endlessly renewed. The connection is not only physical but emotional. Oceans inspire awe with their vastness, their tides and storms, their power to both calm and terrify. Tears are oceans made personal, waves reduced to a scale you can hold in your hand. They rise when joy overwhelms you, when grief cannot be contained, when empathy connects you to another. Both oceans and tears are expressions of water's power to hold meaning, to carry more than just molecules. They embody memory, feeling, and life itself. Scientists have found that the salts in your tears mirror, in small ways, the composition of seawater. This is not coincidence but heritage. The first life emerged in the oceans, and every cell within you still carries that history. The fluid around your cells echoes the chemistry of ancient seas, a reminder that life never truly left the water. When you cry, you are releasing drops that recall an origin billions of years old, when the first living things floated in salty oceans under a young sky. The cycle continues endlessly. Water evaporates from the sea, travels as clouds, and falls again as rain. Some of it enters the soil and the roots of plants, some flows through rivers, and some becomes part of you. Later, it returns, through breath, sweat, or tears, always moving back into the world, never lost. You are not separate from the oceans. You are part of them, and they are part of you. Every drop within you has already seen countless worlds before finding its way into your body. As you lie here tonight, think of that connection. The water in your veins once drifted as vapor above the sea, once froze into a snowflake, once rested in the tide pools of ancient earth. Now it rests within you, flowing quietly, rising as a tear if emotion calls it forward. Beyond your window, the oceans continue their endless rhythm, waves rising and falling with the pull of the moon. Within you, smaller waves move just as surely, connecting you to that greater sea. In every tear is the memory of oceans, and in every ocean is the reflection of us all. In the quiet vastness of space, water does not stay confined to a single world. It moves freely, carried by gravity and time, appearing in places both familiar and strange. A molecule of water might drift in a cloud between stars for millions of years, then freeze inside a comet at the edge of a solar system, then later be delivered to the surface of a planet. Its path is not linear but cyclical, weaving across distances so immense that they defy imagination. Water is not just Earth's treasure, it is a traveler of the universe. Astronomers have discovered its presence far beyond our planet. Telescopes detect the signature of water vapor in the atmospheres of giant planets and even in the skies of worlds orbiting distant suns. Ice coats the surfaces of moons, hiding deep oceans beneath layers of rock and frost. Geysers erupt from cracks in the crust of Enceladus, spraying plumes of water into space. Europa holds a global ocean under its icy shell, warmed by the tidal pull of Jupiter. Even in the depths of interstellar clouds, where new stars are born, frozen water collects on dust grains, waiting for the chance to join new systems. This cosmic distribution tells a story. Water forms naturally wherever hydrogen and oxygen meet, and those elements are among the most abundant in the universe. Once formed, water clings to dust, to rocks, to icy bodies, and is carried along by gravity into ever-changing orbits. It can survive journeys across billions of years, moving from one environment to another, shaping planets and moons, and perhaps providing the conditions for life wherever it lands. The journey of water is marked by extremes. In one place it may boil away under the glare of a star, in another it may freeze solid for eons in the cold of deep space. It can become part of a geyser, erupting from a moon, then drift outward to join a ring around a planet. It may even be found in galaxies far beyond our own, carried in the same molecular clouds that give rise to stars. Each new discovery reinforces the truth that water is not confined, it is widespread, and it is always moving. On Earth, it feels ordinary, present in rivers, clouds, and oceans. But to step back and see it on a cosmic scale is to realize that every drop here is part of a far greater circulation. The oceans that lap at our shores contain molecules that once traveled through interstellar space. The vapor that drifts above us carries the same chemistry seen in distant galaxies. To touch water is to touch something that has not only traveled across time but across the stars themselves. As you settle tonight, picture water as more than a local presence. Imagine it drifting quietly between suns, frozen on comets, locked in alien oceans, and falling as rain on worlds we have not yet seen. It is a universal traveler, moving endlessly, never destroyed, only reshaped, carrying with it the potential for life wherever it goes. In every drop lies not only the memory of Earth, but the wider story of the cosmos itself. Imagine Earth from far above, turning slowly against the black canvas of space. From that distance it looks serene, a blue world wrapped in thin swirls of white cloud. Yet that blueness, the oceans that define our planet, is the result of a balance so delicate that even the smallest changes could have made Earth unrecognizable. Water is the element that makes our world habitable, but it is not guaranteed. It exists here only because the planet struck the right balance of distance, atmosphere, and geology. In the vastness of the cosmos, such a combination may be rare. Earth orbits at just the right distance from the Sun, not too close to be scorched dry, not too far to freeze solid. This narrow zone is sometimes called the habitable zone, and within it liquid water can persist. But distance alone is not enough. Venus also lies within this zone, yet its oceans boiled away under a suffocating blanket of carbon dioxide. Mars, too, once had rivers and lakes, but its thin atmosphere allowed its water to escape into space. Earth alone kept the right mixture of atmosphere and magnetic protection, the right geological activity to recycle water and gases, and the right climate regulation to allow seas to remain stable for billions of years. The oceans do more than fill basins. They regulate temperature, absorbing heat during the day and releasing it slowly at night. They drive weather patterns, moving warmth around the planet through winds and currents. They dissolve carbon dioxide, stabilizing the atmosphere, and provide the medium in which life first arose. Without oceans, Earth would swing between extremes, too hot and too cold, too dry or too volatile for complex life to thrive. Every raindrop, every wave, every glacier is part of this fragile system, maintaining the balance that allows life to flourish. This balance is not permanent. Ice ages have advanced and retreated, shifting coastlines and reshaping ecosystems. Volcanic eruptions and asteroid impacts have altered climates, sometimes dramatically. Yet water has always remained, cushioning these changes, keeping the planet from slipping into permanent extremes. Even so, the margin is narrow. A slightly smaller Earth might not have held its atmosphere. A slightly larger Earth might have kept too much, suffocating life before it began. The oceans, you know, are the product of finely tuned chance, a balance struck among countless variables. To realize how rare this may be, one only has to look outward. The solar system is filled with dry, barren worlds and frozen moons. Some of those moons, like Europa or Enceladus, may hold oceans beneath their icy shells, but they are hidden, locked away from sunlight, perhaps never reaching the surface. Earth is unique, not because water exists, but because it exists here in the open, flowing freely across continents, evaporating into the sky, raining down again, and inviting life to cover every corner. Finding your rest, picture Earth turning slowly, its seas shimmering under sunlight. That shimmering is not ordinary, it is the reflection of balance, fragile and rare. The water that fills this planet has kept it alive through ages of change, and it continues to sustain you now. Every drop is part of the delicate equation that makes Earth habitable. To live here is to be part of that balance, to drink from the oceans of chance that the universe has offered so sparingly. For as long as there have been people, there have been rivers, lakes, and springs shaping the way communities lived and the way they understood the world. Water was never just a resource to drink or a place to fish. It was a force that gave rise to stories, rituals, and symbols that bound societies together. Across every culture, water carried meanings that reached beyond the physical. marking it as something worthy of reverence, something that stood at the boundary between the human and the divine. In the earliest cities along the Tigris and Euphrates, the yearly floods were seen as gifts from gods, a rhythm that allowed agriculture to flourish in otherwise dry land. The Nile, too, was treated as a lifeline, its rise and fall watched with ceremonies, songs, and offerings. For the ancient Egyptians, its waters were not just useful, they were sacred, embodying cycles of death and rebirth mirrored in their beliefs about the afterlife. Far to the east, rivers shaped other traditions. In India, the Ganges became more than a body of water. It was personified as a goddess, a living presence believed to carry away impurity and bring spiritual liberation. To step into its current was not just to bathe but to be renewed. In China, water symbolized harmony and balance, woven into philosophies that saw it as a model of adaptability and strength. In the deserts, where springs were rare, each one became a shrine, guarded and honored as the breath of life itself. Water also found its place in creation stories. In many traditions, the world began not with land but with endless seas. From those waters, the earth rose, and life followed. In Mesopotamian myths, primordial waters existed before gods and men, the foundation of all that came after. In Norse tales, life began when cosmic ice melted under the touch of fire, creating the first living beings. The image of water as the source of existence appears again and again, a thread linking cultures that never met but drew the same conclusion. Life and water are inseparable. Ritual practices reflect this reverence. To immerse, to sprinkle, to wash, these acts appear in ceremonies across time and place. In Shinto shrines of Japan, worshippers rinse their hands before approaching the sacred. In Christian traditions, baptism with water symbolizes transformation and belonging. In Islamic practice, water is essential for ablution before prayer, a physical cleansing that prepares the spirit. Though the details differ, the message is the same. Water purifies not only the body, but the soul. What unites these traditions is the recognition that water is both common and extraordinary. It flows through rivers, falls as rain, fills wells and jars, and yet it has always been seen as a bridge to something higher. It nourishes crops and quenches thirst, but it also carries meaning, memory, and myth. As you let your mind drift tonight, think of those countless rituals at riverbanks and springs, of voices chanting by moonlit waters, of hands lifted to catch droplets believed to hold blessings. The water they touched is the same water that moves through the world today, ancient and unbroken. For humanity, water has never been just matter. It has always been a symbol, a sacred stream flowing through memory, connecting people across time with the eternal. Hold a drop of water in your hand and watch the way it trembles with the slightest movement, a perfect sphere of clarity. At first it may seem ordinary, nothing more than a bit of liquid that slips through your fingers. But that drop is older than the earth itself, its atoms forged in the first moments of the universe. Within it is a story that began billions of years ago, long before oceans spread across the planet, long before life stirred in the seas, long before there were hands to hold it. The water you touch tonight is not new. It is part of a cosmic journey that has never stopped flowing. Think of how far it has traveled. The hydrogen inside it was born in the first minutes after the Big Bang, when the universe itself was still a glowing fire. The oxygen was created inside stars, released when they exploded and scattered their riches into space. Those atoms met in dark molecular clouds, forming water molecules that froze onto dust grains and drifted across light years. Some were carried into comets and asteroids, preserved in ice and rock for eons. Others were drawn into the swirling cloud that became our solar system. From there, collisions and impacts brought them to Earth, where they joined with countless others to form oceans, lakes, rivers, and rain. Every drop you see has followed some version of this path, moving endlessly through time and space. The drop in your hand may once have fallen as rain on volcanic rock in Earth's earliest days. It may have flowed through rivers that carved the first valleys, or pooled in the shallow seas where life began. It could have been part of a glacier that covered continents, or a wave that touched the shores of lands long since vanished. It may have moved through the body of a dinosaur, a fish, or an ancient tree. It may have evaporated into clouds above forgotten civilizations, only to fall again and again as rain. Through every stage, it remained what it is: water, always the same in essence, always moving forward in its journey. Water's constancy is what makes it timeless. It changes form but not identity, shifting from vapor to liquid to ice, always ready to flow into the next chapter. The drop you see tonight is both ancient and new, both a memory and a beginning. It is part of the oceans that give Earth its color, part of the rain that nourishes crops, part of the tears that carry human emotion. To hold it is to touch the same substance that has passed through comets, glaciers, rivers, and countless living beings, each time leaving and rejoining the cycle. As you rest, think of that drop not as something small, but as something vast. Within it lies the history of stars, the memory of worlds, the essence of life itself. The water in your hand is the water of creation, recycled across billions of years, and it will continue long after you are gone. It is not only part of you tonight, it is part of everything, a traveler that carries the story of the universe in its quiet flow. To hold it is to hold time itself, liquid and eternal. Close your eyes and imagine a current that never stops moving. It does not begin in one place or end in another. It circles endlessly, changing form but never ceasing, connecting stars to planets, oceans to clouds, rivers to living beings. This is the eternal flow of water, the quiet thread that ties together the story of the cosmos. From the beginning, hydrogen and oxygen drifted apart, born in fire and scattered across galaxies. When they met in the dark, they became water, and from that moment the journey began. Ice formed on dust grains, comets carried it across space, and planets caught it in their gravity. On Earth it gathered into oceans, rose as vapor, fell as rain, froze in glaciers, and melted again into streams. With every change of form, the flow continued, weaving through billions of years without pause. The seas rose and fell with the shifting of continents. Ice ages locked away water for centuries, then released it in floods that reshaped the land. Storms circled endlessly, pulling vapor from the ocean and returning it as rain. None of this ever ended the story. Every molecule that once fell on a primeval forest still moves somewhere in the cycle today, perhaps drifting now as mist or locked again in snow. The continuity is unbroken, the rhythm eternal. Water has flowed through every living thing that has ever existed. It moved through the cells of the earliest organisms, through the sap of trees in the first forests, through the blood of animals long extinct. It flows through you now, sustaining your body, carrying signals, cooling and nourishing every part of you. When it leaves, it does not disappear. It joins the larger circulation once again, ready to become part of another life, another chapter. What makes this flow extraordinary is its persistence. Stars are born and die, mountains rise and erode, civilizations appear and vanish, yet water endures. It moves quietly through every change, connecting one age to the next. To follow it is to trace the history of Earth, but also the history of the universe itself, for the same molecules drift in distant galaxies, joining clouds that will form new stars and worlds. Let yourself imagine not a single drop, but the entire river of time, flowing endlessly. Picture it winding through nebulae, freezing onto comets, cascading as rain, circling in oceans, flowing within you, and continuing long after. You are part of that current, carried for a while, then released again into the wider stream. There is no beginning and no end. Only movement, only transformation. This is the eternal flow, the rhythm that binds creation to the present and carries it forward. To feel its presence is to know that you are never separate from the cosmos. You are held within the same current that has always moved, that will always move, weaving all things together in its endless passage. Good night from Sleeping with Science.